So hopefully you had a chance to look at those two anyways. The first one where you're just doing one choice. The sample space is pretty much, that picture is good enough, right? But if you had to write the sample space, there's three outcomes, 0 or 5 or 10. Three outcomes, okay, in total. And what's the probability that the 5 is selected? This is not trying to insult your intelligence, but just to remind you that the basic probability formula we looked at is favorable over total, right? If the event you're looking for is the 5 is chosen, there's one outcome that meets that, that's favorable to that, and total is 3. So it's 1 out of 3, right? Even if you have things where it's combined, two things combined together, okay? This is called related events. Events that are tied together here. There's two things you're doing. You're choosing one from here and one from here. You might say, well, there's 3 things that can happen here and 3 things that can happen here, so it's 6 altogether. Or somebody might say it's 9 altogether. Which one of those is it? It's maybe not so obvious when you look at this, right? The fact that it's an and in the middle here. If you make a tree diagram, like it says to make it both ways here. If you make a tree diagram, you could get 0 or 5 or 10 out of the first one, and then you could get 5, 10, or 20 out of the second one, right? How many outcomes are there going to be? There's going to be 9, right? 5, 10, 20. You could write down what they all are, tree diagram, or the table. My guess is that you'd think the table is easier. I think it is. If you make the table for this thing, this is A, this is B. Put the numbers there, 0, 5, 10, 5, 10, 20. Your table shows what all the possibilities are, and it shows pretty clearly there's 9 outcomes there, right? If you fill it out, this is a total of 5, this is a total of 10, 20, 10, 15, 25, 15, 20, and 30. There's 9 total outcomes, right? The fact that this is a multiplication, we've already seen this with combinatorics. The fact that that's a choice, you're making an and in between there, right? You get to choose one out of there and one out of there. There's 9 outcomes. If this said or, right? If someone said you can choose one of these 3 or one of these 3, how many different outcomes would there be then? How many different ways could you make the choice? 6, right? Because there's only 3 there. If there's an or, you're sort of adding, and I think we've already gotten that more or less. When you combine and, you're putting the two of them together and you end up multiplying, right? Right now here, this is an and. If you want to come up with the probability here, right, that the sum of the two bills is 10. So I'm going to put probability sum is 10. You're just, again, you're counting favorable over total, right? Favorable over total. Favorable over total, what is that in this case? There's 9 outcomes in total, and of those 9, which ones are we looking for here? There's 10 and there's 10, right? So it's 2 out of 9. There's 2 favorable out of 9. We haven't done any kind of shortcuts or anything up to this point. All we've done is write out the sample space and count the outcomes. Right? Write out the sample space and count the outcomes. We're going to look for shortcuts on how to find these things without writing out the whole sample space. If someone asks you a Lotto 649 question, you certainly wouldn't want to write out what all the possible tickets are and then count. We want to count it in a more efficient way. But for now, this is the way we're doing things. We're going to look at shortcuts here on some of these things. Okay, eventually. This is written out for you, the sample space here, to make it easier for you, I think, because that's a big sample space to write out. We're looking at related events, right? Events that happen together. So we're looking at red card, jack, card that's not a jack, red card and a jack, red card or a jack. We're taking the two events, jack, which we can use a J for, and red card, which we can use an R for. Okay, so those are the two events that we're going to use. I'm going to use R for card is red, and J for card is a jack. And we'll use some symbols, right? Because then you can use, when you do put a P with something in brackets, that means probability of that. So we want to look at what's the chance that this is a red card. I think we already know that, right? But we can highlight it here on the thing. Card's a red card. What do you have in total here? How many total outcomes are there? 52 cards, right? How many of those are red cards? How many of those 52 are red cards? Half of them, right? 26. So you could either write 26 out of the 52 cards are red, or of course you could reduce it down and say 1 out of every 2 cards is red, or half the cards are red. Either one of these has some meaning in the situation. It isn't that you always have to reduce things down. It's up to you. You can leave it like this if you want, or you can reduce it. Probability that something's a jack. I'm going to highlight that with a different color on here. The jacks are right here, right? There's how many jacks out of the whole thing? Out of 52, there's 4 of them, right? If you wanted to reduce it down, you could. 1 out of 13. So you have 26 out of the 52 cards are red, and 4 out of the 52 are jacks. Now we're looking at these things particularly that are related, right? Related events. One event that's related to probability of a jack is probability the card is not a jack. How would you use symbols for this? You don't want to make up another symbol for that. You put, what do you do? Yeah, the line over the top. That means not a jack. Okay, this thing right here, this line means not whatever the symbol represents. Okay, not a jack. That's what that line means. We could go over here and count. How can you count without going 1, 2, 3, 4, 5? What can we do? Chance it's not a jack. Given that we already did this and counted this, how much? How many is it? You're afraid to say? How many? What's the chance it's not a jack? Isn't it just? Yeah, it is, right? It's all the rest of them. But that's one of the concepts here is if you know the probability of something happening, you also know the probability of it not happening, right? Without counting again. If you know that the probability of getting a jack's 4 out of 52, the probability of not getting a jack's 48. That doesn't sound very useful to know that. Or you could reduce it down here, 12 out of 13. But sometimes it's going to be easier to calculate this than this. And you'll calculate things indirectly by calculating the chance of it not happening. All right? That's actually called the complement. There's a little box down there. If we can skip down there for a second. The first part of this related events box. The complement of an event is the chance that it does not occur, right? The event that A does not occur is a complement of the event A. And we've already used that symbol, right? The two of them together have to add up to 100%, right? This is like the 1 out of 13 and the 12 out of 13 have to add up to 13 out of 13 or 1 or 100%, right? The chance that it rains today plus the chance that it doesn't rain today, even if we don't know what those numbers are, they have to add up to 1, right? If there's a 90% chance of it raining today, there's a 10% chance it's not going to rain. Those have to add up to 100% because those are the only two things that can happen. It rains or it doesn't rain. Okay? If you've used Venn diagrams before, you probably did in kindergarten and stuff like that. You used Venn diagrams where they give you 2 hula hoops or something and said, now here's a bunch of things that are red and are different shapes, or they're different colors and different shapes or something like that. And they said, put all the red things inside this circle and all the squares inside this circle. And so if you had a square that was red, where did it go? in the middle. You've seen Venn diagrams before, right? If you had a rectangle that was red, where did it go? Well, it's red, but it's not a square, so it goes in here. I made it a little bit too big, but it goes in there, right? And if you had, what kind of thing would go in here? A blue square, maybe, right? And then what would go outside? A question mark, exactly. Good answer. Question mark would go outside, right? Anything that doesn't fit in there, I'm not trying to insult your intelligence, but we're going to use Venn diagrams to think about some of these things.